Bismillahirrahmanirrahim. Assalamu alaikum. So today we're planning to complete this chapter in the Clojure workshop, functions in depth. Hopefully we will cover this in this session if there's no load shedding or some other unforeseen issue. So yeah, let's just get started. Okay. Variatic functions. Haven't heard about it before. And multi-methods. Okay. Restructuring. Restructuring is basically removing data elements from a structure or disassembling a structure. For example, here if we're giving this tuple a vector containing two values which are the coordinates of some where, we can print those as follows. For example, print coordinates, it takes a single argument coords, which is a vector containing two elements. So here we say latitude is the first in the coordinates and longitude is the last element in the coordinates, and then we can simply print that as follows. This is the normal way of doing destruction, for example, without any specific syntax pattern for this thing. But Clojure also provides some built-in syntax to support destructuring as well. Okay, yeah, this is kind of like, for example, in Python, if in Python I would do this let run is equal to towards, and it would automatically store the first one in here and the second one in here. Here we can also do something like that. For example, here we're saying let and lon or coordinates. So the first value would be stored in latitude and the other one would be in longitude, and then we can use same string or expression as before. In this case, A would be assigned 1 and B would be bound to 2 and C to 3, and then we can print that. And we can use lists as well. Example here, again A would be bound to 1 and B to 2 and C to 3. Okay, this is the previous way of doing things. For example, to get a value related to this key, we can use this key as a function, and it would get us the value associated with this key in this sequence, and we're binding it to let. This is the associative destructuring technique, where this is kind of like a map. Curly braces, we start with curly braces, and then this is the key or the value which we want to be bound to, and here we're saying that keyword let should be binded to let, and keyword lon should be bound to lon, and name to airport name, and then we can use those in our expression later on. And if they have the same name, for example let, lon, etc., then we can use in a simpler way, where instead of specifying each and every one separately, we just specify keys and give it a name. I guess this would work. For example, let me just let 1 long 2. So if I call keys or keys, can I call keys on this? No. How about keys? Just keys. No. So it's not a function really, but here we can use this syntax where we say that keys are let, long, and name, and these will be assigned their respective values inside. For example, here the keyword's name is also let, so it would be assigned to this let value as well, and we can use it in the expression as before. Here we're creating an airport function, not a function, airport variable or binding global variable airport, which contains this data, which is a map. And then we are defining a function print coordinates, and we're using the associative shorter way of reconstruction when the names are the same. and yeah, it's working fine. Okay, parsing fly vectors data with sequential destructuring. Did we do it in a separate file, or just let's go through this? This is the data. For example, this is the flight ID, fly vector's internal ID. For bookkeeping, this is the passenger's name. This is some information regarding that, and I guess we don't have to process this. And these are the flight coordinates. Flight is a tuple of two coordinate points. For example, this is the first coordinate point, this is the first coordinate point, and this is the second coordinate point. Similarly, this is another flight data. Okay, let's just bind this to our booking, and then we can call the what is value of booking. Can we pretty print it? Yep. Okay. Okay, let's just create a binding block ID, then there's customer name, and then some sensitive info, then flight 1 and flight 2, but there's no flight 3, I guess. This is flight 1, this is flight 2, and this is no. Notice that flight 3 was found at value in data. Okay, if we try to bind something that isn't present, then it would be bound to nil. In the booking data, okay, and then we can print line ID customer name flight 1, flight 2, flight 3. Oh, nice. It's working same. It's printing customer ID, then name, and then flight IDs. For example, this is flight 1 and this is flight 2, and the flight 3 is nil because nothing is present here to be associated with flight 3. Okay, so now we want to add big booking. We want to conjoin booking and some new data. And just let me copy paste this new data and we do yeah. Right. So in this, and then we can, for example, here we're binding big booking to this new data, and then when we're keying, okay, yeah, this is the const block, for example, where we're conjoining, and then these are the remaining values that we want to bind. Customer name, sensitive info, flight 1, flight 2, flight 3, using big booking data that was symbol that was assigned here, and then we can print, just copy paste this one, and here now there's no nil value for the flight 3 because we've already assigned some further flight data as well, so we can also use flight 4, I guess, as well. Yeah, and this flight was ignored even though we didn't specify it. For example, we didn't specify flight 4 here, so instead of throwing an error, it just simply ignored it. Okay, and to ignore something we can use underscore here. For example, to ignore the ID or the sensitive info, we use underscore there. So yeah, it would ignore that value. We learned about this character as well, which is used for variable number of arguments, and we can use that here instead of using flight 1 and flight 2 and flight 3 and flight 4 and checking to see if those are nil and then counting the values that aren't nil. We can use the add character, and it would add all the remaining flights to this flights data flights symbol. For example, here we don't want the ID, we just want customer name, we don't want sensitive info, and after that everything should be bound to flights, and we can count that. We're printing count flights, so 2 values were bound to flight, and if we use this one big booking, then 3 values or 4 values would be bound to flight. This function takes a flight as an input and prints it in a formatted, good format, nicely formatted way. For example, here we're assigning lat1 lon1 and lat2 lon2 to flight, or flight to lat1 lon1 and lat2 lon2. So yep. And then we can simply use those lat1 and lon1, lat2 and lon2 variables. Instead of doing this nested retrieval thing, we can break it down into multiple steps as well. Here these are multiple let blocks. For example, first where the departure coordinates and arrival coordinates, we are finding values from flight to those first, and then using those we are extracting the lat1 lon1 and lat2 lon2. And then in the print booking function, just like before, we're assigning everything after the sensitive information to the flights data structure, and then we're counting it, and after that we're printing 3 flights. For example, let flight 1, flight 2, flight 3 flights. If it's not null, if there is some information here, then we want to print it. If it's nil, then print. If it's not nil, then print. So it will print the first 2 values, but it won't print the last because there's no value in the third flight in the original data. Okay. Okay, before we had sequences or vectors to work with, and now this time we're working with maps. So it's the same data but in maps. For example, this is ID, customer name, some sensitive information, and then some flights information, and where flights is a vector containing other maps. For example, here the first flight is, it also specifies from latitude this and the name of the place as well, to latitude this and the name of the airport or place. So let's just define the mapjet booking data. And then we can use the associative destructuring using the keys. For example, let we want the keys, customer name and flights. These are the only keys that we're interested in, and we want the values from the mapjet booking, and then we can simply print those. Customer name, booked, count, flights, So Alice Smith booked 2 flights. This looks more readable and more succinct and concise than the one we were using before. And to print the mapjet flight details, we can use, for example, here it's taking a flight, and then let keys from and to would be bound to the values from and to, and then we can use those to bind to let 1 and lon 1 and let 2 and lon 2, and then use those for printing. Okay, so okay, here we're first binding values to from and then using from, but here we're directly using the from. For example, instead of bounding to this local symbol from, we're directly using the value or the key from in the database. For example, here we're binding the value of let and lon in this from hash map to let 1 and lon 1, similarly to as well to 2. And here, just like before, we're just checking to see if the value flat 1 is not nil, then print it, and it should work the same way. It's the same logic as before. Now advanced call signatures. Arity is the number of arguments a function can take. For example, If a function takes only one argument, then it has a singularity. If it takes multiple arguments, for example 1 or 2, then it has multipolarities. Okay, so we can use the restructuring techniques in our arguments as well. For example, here we are going 2 layers deep in accessing the value and specifying it to be lat1 and lon1. For example, if a flight was provided, here these values were provided, so we're first going into this outer vector, and then we're going into this vector, and there we're specifying that this is lat1 and this is lon1, and then this is lat2 and this is lon2. That's cool. And we can do the same with the maps as well. So we're going to this from key, and there we're assigning this lat value to lat1 and lon value to lon1. And we're not using the shorter syntax, for example the one with keys and automatic name binding, because these both are lat and lat, so they would conflict with each other. That's why we're doing it this way. In C++, this is called function overloading. So here we want to specify different implementations based on different arguments or number of arguments. For example, defn no overloading, it only takes one kind of argument, which is empty arguments, no arguments, and prints this. But if we want to define overloading, then here if no arguments were provided, it would do this. It would return this statement. If a single argument was provided, it would execute this, and if 2 arguments were provided, it would execute this line of code. So we're defining different functionalities based on the number of arguments. So if we don't provide any argument, only the first one, this expression would be executed. If we provide a single argument, the second, this expression would be executed, and if you provide 2 arguments, this expression would be executed. And if you provide 3 arguments, it would throw an exception, that is arity expression, wrong number of arguments. we're defining a symbol weapon damage which has this value, and then we're creating a function called strike, which either takes a single argument or two arguments. If a single argument enum is provided, then strike calls enemy, and with this fists. But can we access it directly like that? We haven't referenced the weapon damage variable anywhere except here. Yeah, we just have to provide the weapon and it would extract that from the weapon damage. So we're by default we're saying that if no weapon is provided, then the default weapon is fists, and we'll call this again. So this is strike is calling itself again with two arguments. So that's how you do default arguments. So variadic function is, I guess, the function that can take variable number of arguments. We have functions that take a variable number of arguments. In documentation of string, it either takes no arguments or a single argument, or single argument and a variable number of arguments. Let's take a look at the source of string to see how it's implemented. So the implementation this is the metadata, and here it either takes no arguments, returns an empty string, or it takes a single argument, and if it's nil, then it would return empty, otherwise it would convert it to string. And if there are multiple arguments, then we're defining an anonymous function, string builder and more. If there are more, then we want to recurrently call string builder, append string first and more next and more string builder. Yeah, this seems complicated and above our understanding for now. Define welcome player and friends. In line string welcome to the parentheses, first we say player, and then when sequence friends, example, what was doing? Sec return the sequence on the collection. If the collection is empty, returns null. So while friends isn't empty, yeah, this is kind of like while, I guess. When sequence friends, when friends is not nil, print line string sending on friends and request to the following players. So you dot string join, and we're joining the thing. Oh no, it's not a while statement, it's if statement. It would be executed only once. Welcome John, it would just print welcome John, but if there are multiple arguments, then it would print, for example, this would be John and others would be friends, 3 friends, sending 3 friend requests to the following players, and here we're joining these different string names. Okay, this is a commonly used pattern, if sequence and collection instead of if not empty collection. And instead of doing this, when, etc., we can use the multi-arity mode, etc. For example, here if only a single argument is passed to this function, then it would execute this statement specifying that it's in single pair mode, and if multiple arguments are provided, then it would do this. Okay, time to work in our editor. No folder, open file, open folder, select, and let's just quickly create a new folder. Example, not here, I want it. It should not be inside. Yep. This is chapter 3, and here we want to create a new file, E3.03. Multi-arity Restructuring.Clojure, and first we'll define this data structure in depth, Let's just close that and Alt Z. Not okay. So we're defining a def weapon. We're defining a symbol called weapon damage, which is a map containing fist, staff, sword, and cast iron saucepan with these different damage values. And now let's create a strike function. For example, we'll create weapon strike, which takes in case here these parentheses are optional so that we can easily add multiple arities later on, because we can do this as well. And as we will go with this target weapon, and then we'll define our let block where points are extracted from weapon and weapon damage. Okay, and then if norms is equal to camp target enemy name, what is norms? So we know what camp is. Camp will be provided as an enemy. Example, let's just define the enemy here as well. So camp would be, yeah, here it could be trolls or gnomes, etc. So if camp is equal to gnomes, camp of the target, for example, camp in the enemy or target is gnomes, then do example, then update target health plus points. Otherwise, update target health minus points. Okay. So we're defining a strike function which takes two arguments, target and weapon, and then we're calculating the points using this weapon damage data structure and the type of weapon. For example, if the provided weapon is sword, then it would look up this value sword and assign 100 to the points, and then we're seeing if the camp of the target here, for example, this is the target, equals to norms, then you should add to the health point, and if it doesn't equal to the norms, then you should decrease, update the target such that the health minus points. Update target health using this function with the extra argument points. So this would be kind of like assault target, and here we do this health points kind of like this, but update in just is easier to read and write. Okay, so let's quickly try it. We can call our strike on an ally, and it should increase the health points. And we can call strike on an enemy, and it should decrease the health points from 250 to 150 and from 80 to 180. Okay, now we need to update the strike function so that it keeps in account the armor value as well, which is a fraction. For example, 0.8 means that it would reduce 80% of the damage. So target weapon let points if norms can target update target health points, and if it's not the case, then it should. For example, here we want to define some new statements. Update target. So let armor is equal to either the value of armor in the target or 0. It should be target. Let armor either 0 or armor of target. For example, this would be evaluated first and this would be evaluated second. So we know that R would return the first true value. So if this is true, if there is some armor present, then it would assign that to the armorer. If it's not true, then it would assign 0, and we know that 0 is considered to be a true value, unlike in C++ where 0 is considered to be a false value. And then we can use this to calculate damage. And we control V, calculate damage such that it is multiplied by the points as minus times 1 minus armor. So where is the armor? 0.8. Here it would multiply it by 0.2, so the damage would be 0.2 or 20% only. And then we can update the health by not points but damage. So if we try it now, first let's try it where doesn't contain any armor enemy, and it should work the same as before. Yeah, his health is decreasing by 100, and then we can update the enemy to have some armor, and his armor is increasing just by 20%, and it means 20 here, so it's working fine. Let me quickly update the enemy here as well. Where was the enemy? Control C. Save. Okay, so we want to access, instead of using this let value etc, we want to directly use the restructuring in the arguments, but we also want to save the value of the target as well. So for that there's also a new syntax called as, which we can use like so. For example, here define strike, we're getting the values of camp and armor. For example, here if we see that we're getting the value of armor here and camp here, so camp and armor, and then we are storing the target as well, and the other argument is weapon. So this makes the code more simple. Then we can simply use let points, we can extract the points using this, and then if norms camp we can update, and then simply we can calculate the damage like so. Okay, let's shift F. Okay, so we can also use or keyword to bind something if a key is not present. For example, here keys camp armor, if armor isn't present. For example, here we want to bind armor to 0 if it's not present in the key. Otherwise everything else is the same. Now let's copy this as well. Okay, here first it's define strike, it takes a single argument. If it takes a single argument target, then we want to call the strike function again using two arguments, where the default one is fists, so it would next time it would execute this statement. So here we're destructuring using the arguments. For example, for keys we want to extract the camp and armor value. If armor is not present, then we want the armor value to be 0, and we also want to save the target as well, so we can return it later on. and the other argument is weapon. Here we're extracting the points from the weapon damage that was defined above. And if the camp is norms, then we want to update their health points, increase their health points. And if it's not norms, then we want to reduce their health points by a given damage which was calculated using armor value. Yep, everything makes sense. High order programming. Then there's multi-methods, and then there's an activity. Higher programming means that programs and specifically functions can operate on other programs or functions, as opposed to first order programming where functions operate on data elements such as strings, numbers, and data structures. So basically, for example, in first order programming, functions operate only on other data elements, but in higher order programming, functions can operate on other functions as well. So functions can return other functions and take arguments, take other functions as arguments, etc. We can define our operation such that it takes a function as an input and calls it on some value. For example, here operate is taking two arguments f and x and then calling f on x. So we can call operate, pass it a function and a value. Here we're also calling operate, passing in a function and a value, and it's calling that function on this value. And we can pass in a number of arguments as well by using the ampersand sign. It would call the function on all of these arguments. Here it's not working because this would be a sequence, I guess. That's why. Quickly. Example test plus work on 1 2 3. Nope, it does not. That's the problem. The apply function. Okay, so Instead of applying plus on this sequence, we can use apply plus on this sequence, which would apply this operator on each and every element in the sequence. So instead of doing just f and args, we can apply on each and every one of arguments. And we can return other functions as well. So for example, here random function is defined. It doesn't take any arguments and it shuffles, for example, randomly shuffles these values in a vector. For example, here this is a plus function, negative function, etc., and then simply returns the first value that comes after this shuffling. Now we'll learn about partial functions. Partial takes a function f as a parameter and any number of arguments arg1. Okay, we will carry on after this. Let's just take a quick 5-minute break and we'll be right back after that. Okay, and we're back. So yeah, partial functions. The first of those core utility functions is partial, which takes a function f as a parameter and any number of arguments args1. It returns a new function g that can take extra arguments arg2 and column g with args2. F is called with args1 plus args2. Okay. If marketing adder, which is a partial, takes a function plus and some arguments 0.99, and then it would return a new function g, store it in the marketing order, and then when we call marketing order with this 10 and 5, so it would call f with 0. Plus with 0.99 and this and this. Got it. Okay, this seems powerful. Partial. Next we have composing functions. So we are defining a sample function on some collection which first shuffles the collection and then gets the first element of that collection. And yes, sample would work like that. Or we can use the comp function, which would, I guess it works from right to left. First it would call shuffle function on something, then first on something. Right to left. So it would first multiply it, 2 2s are 4, and then increment it by 1, 5. But here it would first increment it by 1, which would give it increment what by 1? There are 2 arguments, so it can't work. Okay, so now we're using both partial as well as comp together. So we're defining a new symbol checkout. Let's go to the first comp, this and this and this. The comp would first call marketing adder function, then it would call format price on that, and then it would call string on that only, and then it would call a partial on that string only. Okay, with marketing adder, format price, and anonymous function returned by the partial to add the text only. So yeah, instead of using anonymous function, we're just saying partial to return a function. we've seen this syntax before in Clojure from the ground up, I think. Okay, so using this very often and from multiple arguments would result in poor readability of the code, so it should be used sparingly and only when there's a single argument or a single function call. It's exercise time now. And then we have multi-methods and activity. I guess activity would take a lot of time here, but I'm still looking forward to it. A dispatch table is a table of pointers to functions. We can implement it with a hash map where the pointers are keys and the functions are values. Okay, so let's just duplicate it. Let's just create a new file, p3.04 high order. Okay, so first let's define this weapon map. And view table wrap. Okay. So we're defining a weapon function map where fists take a function which has a single argument, health, and if health is less than 100, then it should decrease 10, otherwise it shouldn't do anything. So it's just a single key for now. In case of 150 it won't do anything, but in case of 50 it would decrease 10. And we're calling this as a function. And we can call stop as well. So these fists use stop. So we'll create an anonymous function for source, which would decrease 100 from the original health that was passed. Okay, for cast iron weapon we want to, for example, how about we used comp here? Why didn't we use comp here? $50. So cast iron reduces 100 from the granite 100 and some random number. Yeah, we don't need to use comp here. It works fine as it is. So the source code of identity function is simply just, it takes a single argument and just returns that argument. So for sweet potato we can simply return the identity function. Okay, so the strike function now would look like this, where this is a docstring, and for example if it has a single argument called target, then it would call using the default weapon as fist, and then for weapon you can get the weapon function using weapon and weapon function map, and then we can call this weapon function on the health parameter. For example, update target health and call weapon function. So this weapon function would be called with the parameter or the value of health. That was simple. And if we want to strike with multiple weapons, we can use composition comp function. So here we're updating the enemy health and we're using the comp function. So here first it would call cast iron saucepan, it would attack with that, and then using sword, and the result would be updated in the health. Here we can use apply to create a mighty strike, which would call all the functions in the weapon function map. For example, here Let me just copy paste it so it's better highlighted in the IDE. Here it would take a single argument target, and then it would define a weapon function such that it is a composition of all the values in the function map, which are these functions, and it would apply all of that, apply composition on each and every map value. Wait, yeah. It would pass all of these values to the conf function. Yep, makes sense. Multi-methods. Okay, it's kind of for polymorphism. Got it. Polymorphism is the ability of a unit of code, in our case functions, to behave differently in different contexts, for example based on the shape of the data received by the code. In Clojure we call it runtime polymorphism because the method to call is determined at runtime rather than at compile time. Multi-method is a combination of dispatch function and of one or more methods. The two main operators for creating those multi-methods are def-multi and def-method. Def-multi declares a multi-method and defines how the method is chosen with the dispatch function. Def-method creates the different implementations that will be chosen by the dispatch function. The dispatch function receives the arguments of the function call and returns a dispatch value. This is going to be information jam-packed. Is there an exercise up to that as well? Yeah. Okay, so we're creating the strike function with multi-methods. Strike, def-multi, strike, an anonymous function which takes a single argument m and gets the m from weapon. What? We've created a multi-method called strike. The second argument is the dispatch function, which simply retrieves a weapon in a map passed as a parameter. So we pass the map as a parameter and we retrieve the weapon. The multi-strike function. Okay, because strike was already defined, for example here we've already called strike to unmap or undefine the stripe from the user namespace. We can use namespace dash unmap ns dash unmap and name of the namespace and the function. Name of the namespace is user and the function is strike. This is the multi-method definition, and this is the dispatch function. So now we'll call def method on strike and pass in this. What is this? Dispatch value. Sword. Weapon is sword, and it's returning the weapon. Def method strike sword, it will return the values of the sword. For example, here is health, and target health is minus 100. So it would, wait a minute, here is sword. What is this sword, and what about, where is the sword defined? So it is returning this value. Okay. Okay, we need to go over this again. Def multi and def method. Def multi declares a multi method and defines how the method is chosen with the dispatch function. Def method creates a different implementation that will be chosen by the dispatch function. The dispatch function receives the arguments of the function call and returns a dispatch value. This dispatch value is used to determine which function defined with def method to invoke. Okay, so first here we're creating a def multi strike function, and this is the dispatch method, which is an anonymous function which simply gets the value of weapon from the provided sequence or collection. This is the same thing. So we're creating a strike function. This is the dispatch function. It simply gets the value of the key weapon in the map, and then we're defining a method strike for the sword and providing it this. Okay, it's being provided, this map is being provided, or this map is being provided. Okay, we need to, yeah, let's try it out. Def melt weapon strike, new method strike, multi-method strike is being defined, and then we'll call this on the sword. When a sword is provided as a weapon, and the keys are health and some target is provided. We also need to define but the value of the function should return. So basically these are the arguments and this is the function body. Okay, in the argument here we're using the what is the keyword for that? Restructuring. So this would create a function, multifunction for the strike, a strike multifunction which acts on sword. So where do we call it? Where is it being called? Yep, here we're calling strike function on this data where weapon is sword and target contains health 200 and it should return 100. Okay, so we defined a method called strike on sword weapon, and then strike was called on sword weapon. It has two arguments. For example, one is the weapon sword, and here where first argument was the weapon sword, and the second argument is the target. So we're dereferencing or destructuring. Every time I forget this keyword, destructuring the keyword said that its health should be in the health. Got it. So now we understand what's happening. Similarly, we create a function for cast iron saucepan where its health is -100 as well as some random integer between 50 and 1. I don't know, it's between 50 and 1 or 50 and 0. Let me just quickly see if this something returns random integer between 0 and n. That's between 0 and 50 or 49 if we're being inclusive. And we can also provide a default value as well. For example, default, it should just return the health. Okay, so Okay, let's create a new map user where again unmapping the strike function and removing the strike function from the user namespace. We're creating a def multi strike function which takes a dispatcher, and dispatcher is an anonymous function which is deconstructing based on keys of health, target, and weapon as weapon, and if health is less than 50 then we use finisher weapon. Health is less than 50 then finisher weapon is finisher and weapon. And we define the finisher to be, it doesn't take any arguments, and health it should return 0. And we define the sword and other default methods as before. So now if we strike using the weapon sword and targets health 200, we get 100. And if we strike using the weapon spoon and target health 30, although we haven't defined spoon, but because the health is 30 it would just call finisher. Okay, this is quite difficult. A lot to take in. Now the player entity has a name, health, a position with XY coordinates and where he's facing, for example north, south, east, west, etc. So let's just practice. We'll create a player entity, for example with the provided values, and let's create a def multi move function which take where the dispatcher is facing. First it's calling position on the value, provided value. Position on provided value will probably be player, and so it would call first position and then it would get the facing, and this would be the dispatcher. The dispatch function should determine the dispatch value by retrieving the facing value in the position map of player entity. The facing value could be one of the following values. Okay, so we need to unmap it. Unmap from user namespace the function called strike, and then we'll define it again but with a cleaner syntax using comp facing position. So it would first call position on the provided argument and then facing. Okay. And now we'll create the first implementation. Def method move on the north. If north is provided, then the argument entity, and what we should do is update in entity the position and y incorporated. So in entity it would update in entity the position. For example, first it would go to where it is position and then there the value y and increment it by 1. So yep, this is how we define north. Similarly, move with the player entity and observe the result. So if we move the player, okay, the player was facing north, right? And we move why is it not working? Execution error, null pointer exception. So there is player and there is move function and we're calling move on player. So def method move north entity update in entity position. Okay, let's just quickly, should we unmap it altogether or just let's just define north again, entity, and here position spellings, and if we call move player, yep, before y was 10 and now it's 11, so it's working. South, west and east. For south, yeah, let's just, for the sake of practice, let's just quickly define these as well. Entity and update in entity. First it should go to position and then y and decrement it. And for position, west or face west, same thing, entity update in entity and first go to position and then x and then increment it, and again same thing, def method move west, instead of west now we have to move east, again entity and update in entity and position and x and decrement. And now we can test these using the move functions. For example, if we're facing west, then x should be increased by 1, and if we're facing south, then y should be decreased by 1, and if we're facing east, then x should be decreased by 1. And if def method, if the value is something other than this, then we'll create a function which would simply return the entity without changing anything. So if it's facing a wall, then it would simply return it x10 y10 facing wall. Yep. Okay, now I kind of get it. Okay, it's activity time now, which is always fun. Let's see how complex it is, and I think we can do it. We've been streaming for almost 2 hours now, and this would take, let's hope, no more than 30 minutes. So let's get started. Activity 3.0. Okay, control S. Here are files. So A 3.01, distance cost calculator dot clj, and okay, let's see. Okay. Okay, what was the walking speed and driving speed? Okay, so let's just start by defining the walking speed to be 5 and driving speed to be 70. Okay, walking speed and driving speed. Okay, so we can define these latitudes and longitudes as well. Okay, create a distance. It should take two parameters representing the two locations for which we need to calculate the distance. Okay, so we need to create a function called distance, which takes two parameters and then performs some computation. So distance was this. Is this the value, or is it multiplied by this? What is this number 110.25? I guess this we need to multiply it by this as well. Let's just do that, and if it doesn't match the expected output, then we'll try something else. From Paris to Bordeaux, transport driving distance should be this. Okay. Sequence lat1 and lat2, lat1 and lon1 and lat2 and lon2. So we can simply decompose our value, like for example how we're doing it here, but instead of that we can do this variant. Yep. So let's see if we can lat1 to be lat and lon1 to be lon, and for now we'll just return lat1. Quickly see if this works. I'm going to paste it here and then call distance on lat, where lat is equal to 3 and lon is equal to 2. And if we use that class Clojure.lang bootstrap, so we are calling it. Oh, we need to also pass what was, yep. This is from this sheet. Just a minute. if we call it the number of arguments passed. Okay, I need to look up the syntax real quick. Associative restructuring. We keep forgetting about the syntax. Yeah, that's what happens when you're just starting out. Practice you can. Okay. And just return that one and one. Unused pointing, but we are using. Or not. Okay, so only a single argument flight was provided. Instead of using let, we could choose, yeah, we want to use restructuring inside the how about if we wrap it in a, when would it work? In this context, that wouldn't. Control Z, Control C, Control V. So if we call doc on our distance function, it distance from the number of arguments 1 passed to this. Yeah, it's how about now? What if we just execution error, null pointer exception? Most probably this would work now. So if we have let 3 and ln 2, how about just returning the str.1 and lon1 cancel. Let's remove that and then paste, and then try an empty. It's returning empty, and if there's let 2 and lon2, then it's returning 3, so it's working. But instead of thinking where we can pass from Paris to this, so we can use the from and to keyword. So from Paris to Bordeaux, transport walking. Where Paris. Okay, we can either use a vector for 2 positions, for example Paris and Bordeaux, or whatever, however it's pronounced. Or we can use from Paris and to. So now let's go with from syntax, and it would work kind of like this. We need to wrap it inside another, so from, and then again let 2, let lon2, lon2. So this should work fine. Let 2 lon2, and we can call it like so, from Paris to Bordeaux. So if we just copy paste this and paste it here, so 48.856483, then 2 point this, then 44 point. Here it's working. So our distance, we can provide from and to the distance, and just destructuring it quite right. And then we can now compute this. So we can use the let block for math square root math cos. Okay, where is the formula? Instead of string, we'll define a let block. Okay, so let cos value is math slash cos, right? It's not dot math slash cos, math slash cos, and cos of lat1, that would be the cos value. And then we can define let square root, let square as math dot square of minus lat2 and lat1, and math dot, I don't know if there's square or there's square root, but we can use power, I guess. Math dot power of 2, so that would be lat square, and the other one would be ln square. So this would be math dot power minus ln 2 and ln 1 and 2, and we can take the square root here as well, or yeah, let's just do it in the actual expression here. So we need to multiply by 125. That, so multiply 110.25 with math slash square root of math dash square root of lat square plus cos plus ln square. So let's see how it works. And we copy paste it, and plus cannot be cos 2 last square. Oh, go see, old habits die hard, and it's not what we expected. So how about if we just remove this, would it work? And yeah, we have to remove this because otherwise it's considering it to be a function, and we'll call distance and 4.99, which isn't the same, so I guess we need to include that as well. 110.25 times square root of this square plus cos of lat1 times, or it's times, plus cos of lat1. So this would be executed first. So how about now? Would it work? 461.91, still a little bit of difference, everything else is okay. Again, let's try it again. it's negative of lat2 minus lat1 square, and ln2 minus ln1 square. Cos of lat1, and here we're first multiplying cos of lat1 by ln of ln square, and then adding lat square that, then taking square root of all of this, and at the end multiplying by 110. Distance should be this. Should be 12. I don't get it. I think this should work fine. 491. It's really close, but still not the same thing. Or maybe it's 461 and 4613. You have 49161 and I have 46191. Let me call this the whole thing again, and that is 48.856483, 2.352413, 44.834999, and minus 0.575490. Okay, should we take a look at just a quick peek, because I think this should work. This seems right to me. What if we add first and multiply second? But well, let's just see what they're doing. Oh no, not chapter 2, we want chapter 3. Chapter 3 and activity and REPL and distance lat ln and lat2 ln2. So let degree length 110.25. okay, this thing, and then x is equal to minus lat2 lat1 and y is equal to math cos lat2 math cos of lat2. Why is it lat2? It's lat1 according to their formula, where it is. Let's see, cos of lat1 But if we do cos of lat 2, then would it affect? Okay, let's see what else. Rosie. So they're multiplying cos of lat 2 with minus ln 2 ln 1, and then instead of using method power they're just multiplying it. Okay, so at the end they're just multiplying with math of square root plus here lat square and ln square. Why are they taking the square of this whole thing? They shouldn't be taking the square of the cos as well, right? They're taking the square of it as well. I think their implementation is wrong. Or there any issues? So here taking the square root of this is fine. We want to take the square root of this, but for y, why are they taking the square root of lat 2 as well, or square of lat 2 as well? You see here they're multiplying y with y, but that is strange. And they're taking the cos of lat 2 as well. Here they're taking the cos of lat 1. I'll open an issue for this later. See if I'm not understanding the formula correctly or if their implementation is fault. So what is our current result? Yeah, let's just go with this for now and assume that this is correct, because I think it is. For example, here we're calculating the cos of lat 1 as defined in the formula, and then lat square, here lat 2 minus lat 1 whole square, ln square, ln 2 minus ln 1 whole square, and then multiplying it by this first and multiplying math square root, and math square root first we multiply cos of lat 1 and ln square, and then add lat 2 or add our lat square value and take the whole square root. So yeah, this seems fine. I guess there's some problem with their solution. To compute the duration, we consider an average driving speed of 70 km per hour and an average working speed of 5 km per hour. Okay, now we'll create a def multi-method called generally and its dispatch method is transport. Okay, so they're also defining a course London, Manchester, distance. Why are they? Anyways, create a multi-method call itinerary. It will offer the flexibility of adding more types of transport. Create the itinerary function for the walking dispatch value. Okay, let's create a def method itinerary for walking. It should take as input and two keys from the hash map parameter. So itinerary from London to and transport walking. So yeah, we can get those values. For example, we're start using multi methods. Entity, or instead of using entity we can get the from and to values like so. So I guess they passed this lat1 lon1 and lat2 lon2 instead of using from and to, and we can either from London to Manchester, and then we can find the value or call Manchester. Okay, I don't really see. Yeah, they're just using lat1 lon1, and for itinerary they are keys from to and or they calling the distance function distance from to. But from Paris, if we say Paris, what this mean? Okay, yeah, got it. So I'm really spent right now. Should I take a little break or just, yeah, let's get it over with. So we need to define our distance function expects a from and to. So instead of extracting the values or distant from here, we can, let's say, set keys. Okay, I am forgetting the syntax here a little bit. What was the syntax for hopefully here, yep, keys and name and format. So from to in the keys from target inside this target. Keys from 2. Use it like this without providing any. I guess, so let's just see if we can use it like this. For example, if I use test and here keys A, B, and close that, close that, close that, and just calling string on A and B. Okay, and then call on A1 and A2, and I will revert symbol A in this context, or sorry, it's A and B. Yeah, works. There we'll just go with that, from and to, and then we'll pass this to our distance function. Okay, you can use the decomposer using distance and duration. So we create a let block here. We'll create a let block here, let distance dist is equal to calling distance on from and to. This would return a distance, and then we can calculate the duration using how to calculate the duration of walking. How to calculate the duration? So the distance is in distance is kilometers, cost in euros, and duration in hours. So kilometers, 70 km per hour, average is 5 km per hour. So our duration would be distance, for example, distance divided by walking speed. And then we can simply, we should return cost, which is 0, distance this, duration that. Yeah, let's just turn that, Control V, Control V. So we'll return a new map where cost is 0, distance is dist, and duration is duration. Maybe we shouldn't call it just simple. Will it work now? So if we call our itinerary on this, I think it should work now. So no method in multi-method itinerary for dispatch value walking, but we defined walking here. Itinerary transport walking. Okay, so here for example first we def mult on position, and then we def method on north, this entity and something to be done. So but we defined it on walking. Example here it's in transport. I guess I'll have to look into it a little more. It's nil def method walking paste anyway, walking, and yep, we need to do those as well. And now if we specify walking, it is creating a method, and if we run it on this, then distance is this and duration is this. So it's calculating something. And now about the cost. For the driving, you should use a dispatch table that contains the vehicle associated with the costing function. Create a vehicle cost function dispatch table. It should be a hash map with the keys being the type of vehicle and the values being cost calculation functions based on the distance. Okay, so we create a define a what is it, vehicle cost functions maps where distance should simply use the where keys being the types of vehicle and the values being cost calculation functions based on the distance. So the type of vehicle is sport, and its cost would be calculated like partial on average 0.2 liters of petrol per kilometer, costing 1.5 per liter. But do we get them? Because we don't need. Why is it saying this? we can I think simply use this 1.5, right? Liters of petrol per kilometer, because we aren't specifying how much petrol has. But yep, per liter. Okay, yeah, I get it. So per liter it's consuming this, per kilometer it's consuming this much liters of petrol, and for each liter we have to include 1.5. So I am getting stuck. Let me just quickly create one for driving, and prompt should be same, distance calculation should be same, duration should be same, but the cost calculation we can use the cost to be 0 and use cost. We can use cost calculation to be something and use cost here. The cost should be based on the vehicle type. So it should return the function yeah, I will have to look at partial multiplied by 0.12 and 1.3, 1.3, here's 1.5, 0.07, 1.5, 0.2 and 0.1. Okay, and then how is it being used? Cost is getting the complement vehicle, okay, and we're specifying by the vehicle type and driving distance. So we're multiplying. Okay. Yeah, I get it now. So we need to quickly partial multiply by 0.12 and 1.5, and for Pareto it's partial times 0.07 and 1.5, and for Slata it's partial times 0.2 times 0.1. 0.1. That should be it, or shift F. So now to calculate the cost, we can, here we'll have to add the vehicle as well. Calculate the cost, we can simply first get the vehicle from the vehicle cost function, get its cost, and then multiply that by the distance. It would give us cost, distance, and duration. Do you need anything else? And let's run it on Toyota. So first we'll have to define this, and then we'll have to define this. So there is some cost which is slightly bigger because we're using 1.5 instead of 1.3, because 1.5 is specified in this documentation. And duration, so everything is being calculated, and I think this is better or closer to this example documentation than this example where they're, I don't know why they're doing this. There's an explanation, for example, if the unit conversion from dollar to euro or whatever, and why they're using pause on lat 2 instead of lat 1. So there are some discrepancies here, but we are done with this function. View double app, and yep, we learned quite a bit today. So instead of half an hour, it took almost a complete hour, and I had to consult the source code or solution. Here it was difficult, quite difficult. Mapping and filtering. So in the next chapter we'll learn about mapping and filtering, and this is a quite lengthy chapter. Okay, what is survey? Colleague, very likely. Yep, confirm. Okay, yeah, I'm not interested in filling out this survey at the moment. I'm just too spent up right now, and I think this is enough for today, and probably we'll see each other again tomorrow, inshallah, hopefully. Yep. And